Hi everyone. I hope you found this video helpful. If so, I'd really appreciate it if you could subscribe to my channel, like this video, share it with your friends, and leave a positive comment. Your support and encouragement motivate me to create more great videos. In this video, I've covered all the outlines in the syllabus, as shown in the figure. Center of gravity. Sometimes, it is also called the center of mass. The center of gravity of the object is the point where the whole of the weight of the object appears to act. The weight of all objects acts through the center of gravity. For example, the center of gravity of an apple, a magnet and the person, their weight act downward from these points, like this. The center of gravity doesn't have to be inside the object itself, like as U-magnet. The uniform objects have their center of gravity in the middle. For example, the uniform meter rule, its center of gravity is 50 centimeters marks, as shown. The uniform cylinder solid, uniform sphere solid and uniform cube solid have the center of gravity at the middle, as shown. The object will always balance around its center of gravity. The uniform meter rule can be balanced at 50 centimeters marks, as shown. The people is walking on the rope, as shown. A pencil can be balanced on the finger, as shown. The object will be nice and stable if it has low center of gravity, and wide base area are shown. For example, a conical frustum placed with its wider base on the ground is more stable than when flipped upside down. In the first case, the center of gravity is lower and the base area is wider, so more stability. The second case, the center of gravity is higher and the base area is smaller, so less stability. An object will topple over if a vertical line drawn downward from its center of gravity falls outside its base area, as shown. Exam style question 1. A square broad, of side length x, hangs freely from a nail P, as shown. The board has uniform thickness, and is made from material of uniform density. A second square board, of side length 2x, is made of the same material, and has the same thickness, as the original board. This second board is then hung from a nail Q, nail P and Q are at the same height. What is the vertical distance between the positions of the centers of gravity of the two boards? The first square plate has its center of gravity at its midpoint due to its uniform thickness. Therefore, its center of gravity is located here. The distance PG1 is half the length of the diagonal. We can calculate the diagonal using the Pythagorean theorem. So, PG1 is half the square root of x squared plus x squared, which simplifies to square root 2x over 2. The second square plate also has its center of gravity at its midpoint due to its uniform thickness. Therefore, its center of gravity is located here. The distance QG2 is half the length of the diagonal. We can calculate the diagonal using the Pythagorean theorem. So, QG2 is half of the square root of 2x squared plus 2x squared, which simplifies to square root 2x. Therefore, vertical distance between G1 and G2 equals QG2 minus PG1, which is square root 2x over 2. The turning effect of a force is also known as the moment of a force. It's basically how much a force can make something rotate around a pivot point. Moment of a force is the product of the force and the perpendicular distance from the pivot. For example, when you use a wrench to loosen a nut, you apply a force to the end of the wrench. The longer the wrench and the harder you push, the greater the turning effect. If you apply the force at a right angle to the wrench, you get the maximum moment, as shown. But if you apply the force at an angle, like this, the perpendicular distance decreases, so the moment also decreases, as shown. And if you push directly along the wrench, the perpendicular distance is 0, so there's no turning effect at all, as shown. Work example 1. Calculate the moment about the point P. A. A 4 newtons force acts on the rod at a 30-degree angle, creating a moment about point P, which is 5 meters from the point of force application. We resolve the 4 newtons force into components perpendicular and parallel to the rod, as shown. Perpendicular component is 4 sin, 30 degrees, and parallel component is 4 cos, 30 degrees. The moment of 4 newtons force about P is 4 sin, 30 degrees, multiplied by 5. We get the moment equals 10 newtons meter, in anticlockwise direction. B. A 3.6 newton force acts on the rod at a 140-degree angle, creating a moment about point P, which is 5 meters from the point of force application. We resolve the 3.6 newtons force into components perpendicular and parallel to the rod, as shown. This angle is 140 minus 90 is equal to 50 degrees. The perpendicular component is 3.6 cos, 50 degrees, and parallel component is 3.6 sin, 50 degrees. The moment of 3.6 newtons force about P is 3.6 cos, 50 degrees, multiplied by 5. We get the moment equals 11.6 newtons meter, for 3 significant figures, in clockwise direction. Torque of a couple. Torque of a couple is produced when 2 parallel forces of equal magnitude act in opposite directions and have lines of action that do not coincide. Torque of a couple is the product of one of the forces and perpendicular distance between the line of action of the forces. When the force F1 and force F2 act the rod, as shown, the 2 forces produce the torque of a couple, if they are equal in magnitude, opposite direction, and non-coincident line of action. So, the torque of a couple is the one of force F times perpendicular distance d between 2 forces. Exam style question 3. 2 coplanar forces act on the rim of a wheel. The forces are equal in magnitude. Which arrangement of forces provides only a couple? A. No couple, as the forces are not opposite. B. No couple, as the forces are not opposite. C. No couple, as the forces are not opposite. D. Couple, as the forces are equal, opposite, and have non-coincident lines of action. Exam style question 4. The diagram all show a pair of equal forces acting on a meter rule. Which diagram shows forces that provide a couple and 0 resultant force? A. No couple, as the forces are not opposite. B. Couple, as the forces are equal, opposite, and have non-coincident lines of action. C. No couple, as the forces act on the same line of action. D. No couple, as the forces are not opposite. Exam style question 5. A ruler of length 0.30 meters is pivoted at its center. Equal and opposite forces of magnitude 2.0 newtons are applied to the ends of the ruler, creating a couple as shown. What is the magnitude of the torque of the couple on the ruler when it is in the position shown? Torque of a couple is one force multiplied by perpendicular distance between forces. The perpendicular distance between forces is 0.30 sin, 50 degrees. So, the torque of a couple is 2.0 times 0.30 sin, 50 degrees, which is 0.46 newtons meter for 2 significant figures. Hi everyone. I hope you found this video helpful. If so, I'd really appreciate it if you could subscribe to my channel, like this video, share it with your friends, and leave a positive comment. Your support and encouragement motivate me to create more great videos. In this video, I've covered all the outlines in the syllabus, as shown in the figure. Principle of moments. For a body to be in equilibrium, the sum of the moments about any point is 0. Therefore, the total clockwise moment is equal total anticlockwise moment. Conditions for equilibrium. For a body to be in equilibrium, the resultant force on the body must be zero. And the resultant moment, torque, on the body must be zero. Exam-style question 1. A uniform ladder rests against a vertical wall where there is negligible friction. The bottom of the ladder rests on rough ground where there is friction. The top of the ladder is at a height h above the ground, and the foot of the ladder is at a distance 2a from the wall. The diagram shows the forces that act on the ladder. Which equation is formed by taking moments? The moment about the point A total clockwise moment equals total anticlockwise moment. The clockwise moment about the point A equals W times A plus F times H. The anticlockwise moment about the point A equals W times 2A. We simplify the equation as W A plus FH equals 2W A. The moment about the point B total clockwise moment equals total anticlockwise moment. The clockwise moment about the point B equals F times half of H plus F times half of H. The anticlockwise moment about the point B equals W times A. We simplify the equation as FH equals W A. The moment about the point C total clockwise moment equals total anticlockwise moment. The clockwise moment about the point C equals F times H. The anticlockwise moment about the point C equals W times A. So, A is correct. Exam-style question 2. A uniform rod XY of weight 10 newtons is freely hinged to a wall at X. It is held horizontal by a force F acting from Y at an angle of 30 degrees to the horizontal, as shown. What is the value of force F? We take the moment about the point X. Total clockwise moment equals total anticlockwise moment. A 10 newtons force acting at a perpendicular distance of half of xy from the point X creates a clockwise moment. So, the clockwise moment about the point X equals 10 times half of xy. The force F, acting at a perpendicular distance of xy cos 60 degrees from the point X, creates an anticlockwise moment. So, the anticlockwise moment about the point X equals F times xy cos 60 degrees. We solve the force F equals 10 newtons. Exam-style question 3. A horizontal bar is supported on a pivot at its center of gravity. A fixed load is attached to one end of the bar. To keep the bar in equilibrium, a force F is applied at a distance x from the pivot. How does F vary with x? The weight of a fixed load creates the anticlockwise moment about the pivot, which is always constant. The force F, acting at a perpendicular distance x from the pivot creates the clockwise moment, which is F times x. We apply the principle of moments about the pivot, so total anticlockwise moment equals total clockwise moment. So, F times x equals constant. This shows that the force F is inversely proportional to x. This creates the reciprocal graph. So, B is correct. Exam-style question 4. 4 beams of the same length each have 3 forces acting on them. Which beam has both zero resultant force and zero resultant torque acting? Choice A. The total upward force equals 30 plus 50, which is 80 newtons. The total downward force equals 90 newtons. So, the resultant force is not zero. Choice B. The total upward force equals 36 plus 70, which is 106 newtons. The total downward force equals 106 newtons. So, the resultant force is zero. We take the moment about the point A. The total clockwise moment equals 36 times 50 is equal to 1,800 Newton-centimeter. The total anticlockwise moment equals 70 times 30 is equal to 2,100 Newton-centimeter. So, the resultant moment is not zero. Choice C, the total upward force equals 28 plus 35, which is 63 newtons. The total downward force equals 63 newtons. So, the resultant force is zero. We take the moment about the point, A. The total clockwise moment equals 28 times 50 is equal to 1,400 Newton-centimeter. The total anticlockwise moment equals 35 times 30 is equal to 1,050 Newton-centimeter. So, the resultant moment is not zero. Choice D, the total upward force equals 42 plus 70, which is 112 newtons. The total downward force equals 112 newtons. So, the resultant force is zero. We take the moment about the point, A. The total clockwise moment equals 42 times 50 is equal to 2,100 Newton-centimeter. The total anticlockwise moment equals 70 times 30 is equal to 2,100 Newton-centimeter. So, the resultant moment is zero. Coplanar forces in equilibrium. Consider a stationary lamp of weight W pulled to one side, with a horizontal force F, so that it makes an angle θ with the vertical, as shown in the free body diagram below. To analyze the forces acting on the lamp, we can construct a vector diagram. Draw the weight vector W. Draw the force vector F, connecting the tail of F to the head of W. Draw the tension vector T, connecting the tail of T to the head of F. These angles are θ. From the vector diagram of W, F and T is a closed triangle, with all the arrows going the same way round the triangle. This shows that the sum of these three forces is zero, and that the body is in equilibrium. Exam-style question 5. The diagram shows an experiment to measure the force exerted on a ball by a horizontal air flow. The ball is suspended by a light string and weight 0.15 newtons. The deflection of the string from vertical is 30 degrees. What is the force on the ball from the air flow? The ball is equilibrium, so the resultant force is zero and the vector diagram is closed triangle. Draw the tension vector T. Draw the weight vector W, connecting the tail of W to the head of T. Draw the force vector F, connecting the tail of F to the head of W. This angle is 30 degrees. And this angle is 90 degrees. We calculate the force F by the tangent ratio. So, tan 30 degrees equals F over 0.15. We solve the force F equals 0.087 newtons for two significant figures. Exam-style question 6. The diagram shows a rope bridge that a student makes on an adventure training course. The student has a weight W. What is the tension T in the rope in term of W and θ? The weight W of the student acts downward. The tension T in the string is same due to same string. The tension T in right-hand side is draw, like this. We resolve the tension T into the vertical and horizontal components, like this. The vertical component is T sine θ, and horizontal component is T cos θ. The tension T in left-hand side is draw, like this. We resolve the tension T into the vertical and horizontal components, like this. The vertical component is T sine θ, and horizontal component is T cos θ. A student is equilibrium, so the resultant force is zero. This causes the total downward force equals total upward force. So, W equals T sine θ plus T sine θ. We get W equals 2T sine θ. Exam-style question 7. A sledge slides down a slope at a constant velocity. The three forces that act on the sledge are the normal contact force C, the weight W, and a constant frictional force F. Which diagram represents these forces acting on the sledge? A sledge slides down a slope at a constant velocity. This means that it is equilibrium. So, the vector diagram of W, C and F is closed triangles and their arrows going the same way round the triangle. Choice A is incorrect, because the arrows do not point in the same direction around the triangle. Choice B is incorrect, because the arrows do not point in the same direction around the triangle. Choice C is correct, because the arrows point in the same direction around the triangle. Choice D is incorrect, because the arrows do not point in the same direction around the triangle. Exam style question 8. A ladder is positioned on icy, frictionless ground and is leant against a rough wall. At the instant of release it begins to slide. Which diagram correctly shows the directions of the forces P, W and are acting on the ladder as it slides? The weight W of ladder acts downward. The normal reaction of the ground acts upward on the ladder. No friction between the ground and the ladder due to the frictionless. The normal reaction of the wall acts to the left on the ladder. The friction between the wall and the ladder acts upward due to the wall is rough. So, the reaction force P of the wall acts on the ladder to draw like this. So, B is correct. Hi everyone. I hope you found this video helpful. If so, I'd really appreciate it if you could subscribe to my channel, like this video, share it with your friends, and leave a positive comment. Your support and encouragement motivate me to create more great videos. In this video, I've covered all the outlines in the syllabus, as shown in the figure. Density is defined as mass per unit volume. We calculate the density by ρ equals m over v. Where ρ is density in kilograms per cubic meter, m is mass in kilograms, and v is volume in cubic meter. Density is specific value for each material, meaning that same material will always have the same density. The density of an object can explain whether it will float or sink in a liquid. If the object's density is more than the liquid's density, which cause the object to sink. If the object's density is less than the liquid's density, which cause the object to float. For example, a block of aluminum will sink and settle to the bottom of a liquid. This shows that its density is more than the liquid. A block of ice will float at the surface of liquid, but will be totally submerged. This shows that its density is equal to the liquid. A block of cork will float at the surface of a liquid, with some of it submerged. This shows that its density is less than the liquid. Exam style question 1. The diagram shows the arrangement of atoms in a particular crystal. Each atom is at the corner of a cube. The mass of each atom is 3.5 times 10 power negative 25 kilograms. The density of the crystal is 9.2 times 10 power 3 kilograms per cubic meter. What is the shortest distance between the centers of two adjacent atoms? We calculate the density by ρ equals m over v, rearranging into v equals m over ρ. The shortest distance happens when each atom touches each other, as shown. The shortest difference between the centers of two adjacent atoms is x. We imagine the atom is in the cube with sides x, as shown. So, the volume of the cube is cubic x. Therefore, cubic x equals m over ρ. And x equals cube root of m over ρ. Substituting m equals 3.5 times 10 power negative 25, and ρ equals 9.2 times 10 power 3. We solve the x like this. Then the shortest difference x equals 3.4 times 10 power negative 10 meters for two significant figures. Exam style question 2. In a large container in an oil refinery, 3 oils of different densities are mixed. No chemical activity occurs. The mixture consists of 1,200 kilograms of oil of density 1,100 kilograms per cubic meter. 1,500 kilograms of oil of density 860 kilograms per cubic meter. 4,000 kilograms of oil of density 910 kilograms per cubic meter. What is the density of the mixture? We calculate the density using ρ equals m over v. M is the total mass of the mixture, which is 6,700 kilograms. V is the total volume of the mixture. We calculate the total volume V of the mixture by dividing the mass of each oil by its density and summing the results, like this. We solve the density of the mixture equals 927 kilograms per cubic meter for 3 significant figures. Exam style question 3. 2 solid substances P and Q have atoms of mass MP and MQ respectively. They have NP and NQ atoms per unit volume. The density of P is greater than the density of Q. What must be correct? We calculate the density by ρ equals m divided by v. Each atom of substance P has mass MP and NP atoms per unit volume. So, the density of substance P equals MP times NP. Each atom of substance Q has mass MQ and NQ atoms per unit volume. So, the density of substance Q equals MQ times NQ. The density of substance P is greater than the density of substance Q. We can rearrange the equation like this. So, C is correct. Pressure is defined as the force per unit area. We can write the equation of the pressure as P equals F is divided by A. Where P is the pressure in Newton per meter squared or Pascal, F is the force in Newton, and A is the area in meter squared. We can conclude that the pressure increases as the contact area decreases while the force remains the same. In the opposite way, the pressure increases as the force increases while the contact area remains the same. Pressure in a liquid. Pressure in a liquid acts on an object in all directions. The pressure is higher at the greater depths in the liquid, resulting in a higher force acting on an object compared to shallower depths. Pressure decreases as the object rises through the liquid. The equation of pressure in a liquid is P equals ρgh. Where P is pressure in newtons per meter squared or pascals, ρ is the density in kilograms per cubic meter, g is the acceleration of free fall, which is 9.81 meters per second squared, and h is the depth in meters. We can prove this formula. If the container is filled with a liquid, the pressure in the liquid at the bottom of the tank is the force divided by the base area. The force is the weight of a liquid, which is equal to the mass of the liquid multiplied by gravity. The mass of the liquid is density of liquid multiplied by the volume of the container. The volume of the container is equal the depth multiplied by the base area. So, the pressure at the bottom is equal to F over A. By substituting the force F with W equals mg. Substituting the mass m with ρ v. And substituting the volume V with HA. We can derive the equation P equals ρgh. Work example 1. The diagram shows the water and liquid P, which do not mix. The liquids are in equilibrium in an open U-tube. Calculate the density of liquid P. The pressure at the same level in both arms of the U-tube is equal. There is air pressure to act on both sides of the tube, like this. There is the pressure due to liquid P to act on left-hand side of the tube, like this. There is the pressure due to water to act on right-hand side of the tube, like this. So, the total pressure of left-hand side equals the total pressure of right-hand side. Air pressure and gravity G are cancelled out for both sides, like this. Substituting the depth of liquid P equals 0.01, water density equals 1000 and the depth of water equals 0.07, like this. We solve the density of liquid P equals 700 kilograms per cubic meter. Exam-style question 4. The diagram shows two liquids, labeled P and Q, which do not mix. The liquids are in equilibrium in an open U-tube. What is the ratio of density of P to density of Q? The pressure at the same level in both arms of the U-tube is equal. There is air pressure to act on both sides of the tube, like this. There is the pressure due to liquid P to act on left-hand side of the tube, like this. There is the pressure due to liquid Q to act on right-hand side of the tube, like this. So, the total pressure of left-hand side equals the total pressure of right-hand side. Air pressure and gravity G are cancelled out for both sides, like this. We rearrange the equation, like this. Substituting the depth of liquid Q, HQ, equals x and the depth of liquid P, HP, equals 2x. We solve the ratio of density of P to density of Q equals 1 to 2. Exam-style question 5. Liquid Q has twice the density of liquid R. At depth x in liquid R, the pressure due to the liquid is 4 kPa. At what depth in liquid Q is the pressure due to the liquid 7 kPa? The pressure due to liquid question, PQ, equals rho Q G HQ. Substituting PQ equals 7 kPa and rho Q equals 2 rho R, like this. The pressure due to liquid R, PR equals rho R G HR. Substituting PQ equals 4 kPa and HR equals x, like this. Dividing the equation 1 by the equation 2, like this. We cancel out kilopascal, rho R and G, like this. We solve the HQ equals 7, x, over 8. Exam-style question 6. A borehole of depth 2,000 meters contains both oil and water as shown. The pressure due to the liquids at the bottom of the borehole is 17.5 megapascal. The density of the oil is 830 kilograms per cubic meter, and the density of the water is 1,000 kilograms per cubic meter. What is the depth x of the oil? The pressure due to the liquid at the bottom is caused by the pressure due to oil and water. Substituting rho of oil equals 830, G equals 9.81, H of oil equals x, rho of water equals 1000, and H of water equals 2000 minus x. We solve the x equals 1270 meters for 3 significant figures. Upthrust. Upthrust is the upward force that a liquid or gas exerts on a body floating in it. Upthrust force, also known as buoyant force, is caused by the difference in hydrostatic pressure at the bottom and the top of an object immersed in a fluid. We can write the equation of the upthrust U equals rho GV, where F is the upthrust in newtons, rho is the liquid density in kilograms per cubic meter, G equals gravity in meter per square meter, and V equals immersed volume of the object in cubic meter. We can prove the formula of the upthrust as follows. Pressure at the bottom, P2, is greater than pressure at the top, P1, resulting in a greater upward force, F2, than downward force, F1. This difference in forces, F2, minus F1, is the upthrust F. P1 equals rho GH1. F1 equals P1 times A. F1 is the force due to P1. So, F1 equals rho GH1 A. P2 equals rho GH2. F2 equals P2 times A. F2 is the force due to P2. So, F2 equals rho GH2 A. Therefore, the upthrust F equals F2 minus F1. Factoring rho G A like this. Substituting H2, minus H1 equals H, like this. And substituting A, H equals volume V, like this. So, F equals rho GV. Therefore, we can conclude the Archimedes principle that an upthrust force equal to the weight of fluid displaced by the object. Work example 2. An object in the shape of a cube of side 200 mm is placed in a liquid of density 1.8 times 10 power 3 kg per cubic meter. Its top surface is horizontal and is 350 mm below the surface, as shown in figure below. A. Calculate the pressure from the liquid at the top surface. We calculate the pressure P due to liquid by P equals rho GH. Substituting rho equals 1.8 times 10 power 3, G equals 9.81, and H equals 350 times power negative 3. We solve the pressure P equals 6,200 pascals for two significant figures. B. Calculate the pressure from the liquid at the bottom surface. We calculate the pressure P due to liquid by P equals rho GH. Substituting rho equals 1.8 times 10 power 3, G equals 9.81, and H equals 550 times power negative 3. We solve the pressure P equals 9,700 pascals for two significant figures. C. Calculate the downward force caused by the liquid on the top surface. We calculate the force at the top by F equals P times A. Substituting P equals 6,180.3, and area, A, equals 200 times power negative 3 multiplied by 200 times power negative 3. We solve the force F equals 250 newtons for two significant figures. D. Calculate the upward force caused by the liquid on the bottom surface. We calculate the force at the bottom by F equals P times A. Substituting P equals 9,711.9, and area, A, equals 200 times power negative 3 multiplied by 200 times power negative 3. We solve the force F equals 390 newtons for two significant figures. E. Calculate the net upthrust on the cube. The net upthrust equals force at the bottom minus force at the top, like this. We solve the upthrust F equals 140 newtons for two significant figures. G. What condition needs to be satisfied for the cube to float up to the surface? The upthrust is greater than the weight of the cube, causing the resultant force to act upward. This caused the cube to float. F. Archimedes' principle states that the upthrust on a body in a fluid is equal to the weight of fluid displace. Show that this is true for your calculation in A. 2e. The weight of the fluid displaced equals milligram, substituting m equals rho v. Substituting rho equals 1.8 times 10 power 3, v equals cubic of 200 times 10 power negative 3, and g equals 9.81. We solve the weight equals 140 newtons for two significant figures. This shows that the weight of liquid equals the upthrust. Exam style question 7. A ball has a mass of 0.50 kilograms and a volume of 1.3 times 10 power minus 3 cubic meters. The ball is floating in equilibrium on still water. The two forces that act on the ball are its weight and the upthrust due to the water. The density of the water is 1.0 times 10 power 3 kilograms per cubic meter. What is the percentage of the volume of the ball above the surface of the water? When the ball is in equilibrium, so the resultant force equals 0. This causes the upthrust equals weight of the ball. G are cancelled out for both sides. We rearrange to get the ratio of immersed volume to ball's volume, like this. The density of the ball is ball's mass divided by ball's volume. We solve the percentage of immersed volume to ball's volume to get 38.5%. So, the percentage of the volume of the ball above the surface of the water equals 62%. I hope you found this video helpful. If you did, I would be grateful if you would subscribe, share, like and leave a positive comment. Your support will encourage me to create more content. Thank you.